All right, so for question 8, we're given the graph. Okay, the graph was already done for us. The only work which was needed, which we were needed to do, was to just answer the questions. Nothing of graphing. So the first question here was using the graph to solve the equations. So let's see the equation. This is the equation. Negative 1 over 5 x inside the brackets 12 minus x squared is equal to 1. Okay, so how do we answer this one? So let me just give an example of how it is done. So I'll use something here. So if we can check nicely, the equation that we've been given over here on top, the equation says y, okay, is equal to negative 1 over 5 x inside the brackets 12 minus x squared. So this is what we've been given, and what they want us to find is let me put it here. They want us to find negative 5x, or to solve here 12 minus x squared is equal to 1. So if you're able to see nicely, you find that this and this are the same. So meaning this is y is equal to 1. Okay? Y is equal to 1 is what we need to focus on, because all this thing is equal to y, and it's the same here, which is equal to y. So what we're going to say, this thing will make it y is equal to what is here, which is 1. Okay? So now we graph this equation, y is equal to 1. So we go to the graph. Where is our 1? If we can see, this is 2, this is 0, and this is 2 over here. If this is 2, 1 must be somewhere here in between. Okay, so this is where 1 is. Okay, so we get our ruler, put it there. Okay, graph the line, y is equal to 1. Okay, so y is equal to 1 is, see, this one. Okay, so this is the y is equal to 1. Okay, so now since we have y is equal to 1, we now check the intersection of this line with the graph. So this is where there is the intersection here and right here. Okay, so now we'll check. We'll get let me get the pencil. We'll get the pencil, and then right here where the point is, you draw a line, check what is the x value here. That's the answer. And also here, what is the x value right here? And also here, what is the x value right here? So our solutions will come from the x value here, the x value here, and the x value. Where the intersection is done, the x value is what we were getting. So we can find our space, maybe right here, and then say question 1, okay, we say x will be equal to, what is the solution here? So this is 0. 1, 2, 3, 4, 0.4, negative 0.4. So if you want, you can start with this. Over here, we'll say negative 3.123, negative 3.3. Okay, is our solution there. Next one, x will be equal to negative 0.4. Next, x will be equal to, where right here, what is the value of x? Here is negative 3.1234567, negative 3.7. So these are the solutions. All right, so I guess you are following. So for B, the solutions for B we go the same procedure like I showed on the previous one is what we need to use here. Now, since they're saying y, they're saying negative 1 over 5x inside the brackets 12 minus x squared is equal to negative 2. So now what you're going to do here is just to say y is equal to negative 2. In other ways, when you've been told to use the graph to solve the equations, just get what is this side. You equate them equal to 0. And you need to check, is this stuff same as what is here, what you've been given on the graph? If it's the same, just keep on getting what is this side. So in this case, we're going to graph y is equal to negative 2. So you check y is equal to negative 2 is over here. So graph your line there. So this is y is equal to negative 2. Okay, since we have y is equal to negative 2, we check the intersections here, here, and here. So we say x is equal to, right here, this is negative 3.1234567 So it's negative 3.8. X is equal to here, this is 0.9 because this is 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.9. And here x is equal to 2.9. 2.9. X is equal to 2.9. So these are the solutions for question 1, Roman numeral 1. Okay, so now we go to question 2, where they're saying calculate an estimate of the area bounded by the cave. So we're talking about this cave, okay? Area bounded by the cave. So this is the cave we're talking about. And the line y is equal to 0. So y is equal to 0 is this line, the line which is over here, is y is equal to 0, the x-axis. And x is equal to negative 3. So x is equal to negative 3. You go to where negative 3 is in the x-axis. So it's over here. So this is where it is. This is x is equal to negative 3. And also x is equal to negative 1. X is equal to negative 1 is over here, right here. Okay. So the region that we're dealing with is this one. Let me shade it so that we see nicely what is happening. I'm shading this. So this is the region we're dealing with, region over here. Okay, so now in order for us to find the area here, we can check the shapes that are inside. There is, I think we can use the idea of trapeziums, good, and the idea of rectangles, okay? It's just the idea of shapes being formed on the shaded, or in this shaded region. So there are trapeziums, there are rectangles there are triangles. So what I'm going to do, the easiest which I've found to be working for me is just to use a rectangle, okay? So if you can see nicely, this is a rectangle over here, this one. Okay, it's a rectangle. So you find area of a finished box, just a finished box. So for example, a box, this box, because there are these bigger boxes. So find area of a bigger box. So how do you find the area of the bigger box? Area of a bigger box, which is a rectangle, is L times B. Okay, so the next thing here will be to find the length. For example, from here to here, if we are dealing with this box, any box, because I know there are boxes inside, so any box. So if you're able to see nicely, let me use this box over here. If you're able to see the length from here to here, it's just 1. Okay, that's 1. And then B from here to here is 2. So if you can see, it's just a 2, 2, 2, 2. So you say 1 times 2, you get a 2. So this is the area of a full or finished box. Okay, this is the area of the finished box. I don't want to use the trapezium. If you want, you can use the trapezium. It's okay, it's fine. But I'm going to use the area of or the formula for finding area of a rectangle. So once you do this, you can now find the area of half, okay? Area of a unfinished rectangle. In this case, it will be like this, okay? Or in other ways, you just get this area, the one you've just found here, divided by 2. So here you have something like this. So you find that if the shape or the rectangle has been chopped, the area is this one. If it has been cut, if it is full, the area is this one. So now at this point we check how many rectangles are finished here. How many rectangles are full? How many full rectangles do we have? It's only this one. This one is not full because it has been cut somewhere here, and this one also, it has been cut. This one has been cut. So the area or the number of rectangles which are finished is only 1. So we say 1 rectangle times this area, we have a 2. So we keep this area. The next, how many chopped rectangles? We have 1, 2, 3. It's 3. So we say 3 or 1, whichever you want to start with. 3 rectangles have been chopped times their own area, which is 1. You are getting a 3. So what we're going to do is to get this area plus the other area of the unfinished rectangles, of which you find your answer to be 5 square units. I don't want you to be putting centimeter squared or kilometer squared, because we don't know the measurements here. No measurements has been mentioned, so just put square units. All right, so we're done with this one. We go to the next question. We have been asked to find the gradient of to calculate an estimate of the gradient of the curve at the point, okay, negative 3, negative 1.8. So you go to that point. 3 is over here, negative 1.8 is somewhere here, right here, okay? This is negative 1.8. So what you do, if you want, you can use the idea of calculus. If you don't want to use the idea of calculus, you can just go to that point, make a line like this. Okay, so you see the line should just be touching the point. So once you make that line, you can pick the coordinates along this line. So I've picked this one, which is 2, 4.2.4. So this is negative 4.4. I have a 2, negative 4.4. And also this very one, which is 3, negative 1.8. This one have been given the question, so you can just find, if you want, you can pick the coordinates which are here if you want, but for as long as it's along the line, as long as it's along the line, if you want, you can pick the coordinates here, it's okay. So I've just picked these coordinates, so I'll call these as my A and my B. So coordinates A, we have 2, negative 4.4. B, we have 3, negative 1.8. Okay, so once you get these coordinates, you can use the formula for finding gradient of or finding the gradient, which is this one over here. So once you put that, you can say this is your x1, y1, x2, y2. So what is my x2? Is negative 1.8 minus my what's my y2? Negative 1.8. My y1 is negative. Don't forget the negative. That's why I'm putting the brackets. There is a minus here, and this coordinate has got a negative sign. So negative 4.4 over, what is my x2 is 3 minus my x1, which is 2. So here you do the calculations nicely. You find, let me use my calculator here. So you can get your calculator, you punch negative 1.8 minus negative 4.4. So what are you getting is 2.6. Okay, 2.6 over 3 minus 1 is 1. Okay, of which your answer will just be 2.6, or if you want you can round it off to 3. That's all. Okay, this is the answer we are getting. We go to the next question, and actually before I forget, we need to indicate that this is the B. This is B and this is A. We need to indicate that so that whoever is marking is not facing difficulties to identify which question are we dealing with. So we go to the next question. The next question here, which is B, they said find the equation of the curve for which dy dx is equal to 2x minus 3, where x is equal to y is equal to 3. This is very important. So what we're going to do here is to reverse. Okay, this is derivative. So we're going to find what we call antiderivative of this one. And the antiderivative is just the reverse. We're going to reverse this one by simply integrating. We apply the idea of calculus here. We are integrating with respect to x. So you just integrate this. So you find that you are going to get something like this. Okay, so this is power 1. So 1 plus 1 is 2 to the power. So we have a 2. Our new power is 2. So divide this new power here. If you have a constant like this, when integrating, you just apply the letter that you are respecting. In this case, we are respecting x. So we just put x there. Okay, and then plus c. This is a constant. So now we need to find a constant. This is where the idea of this comes in. So we're going to say y is equal to 2x squared minus 3 plus c. Okay, this is what we're going to say. This one, 2 and 2, they will cancel. So we'll just remain with the x squared right here. That's why I've written this. Now here on dy dx, we just put y. Okay, now we need to find the c. So what is our c? Our c will come from the idea of putting these 3 where x is and y is, because they have said x is equal to y and y is equal to 3. Okay, x is equal to y and y is equal to 3. So these things are equal. So here we're going to put a 3, right here 3, and a 3 where x is plus c. So we solve. We have a 3 here, 9 minus here, we have a 9 plus c. This and this will cancel. We'll remain with 3 is equal to c. So our c is 3. So we come to this point where we say y is equal to x squared minus 3x plus 3, because our c is equal to 3, and this is the solution. Okay, so we move on to the next question. So for question 9a, they want us to calculate the standard deviation. So how do you do it? So we use this formula. Actually, there are 2 formulas. So we use either this or the other one. So we're going to use this formula. We first need to find the mean. Okay, we know that this is mean, so we need to find the mean. So the formula for finding mean is summation of the frequency times the midpoint over summation of the frequency. So this is the formula. So what is the frequency? The frequency are the numbers of learners, of which we have 2. So this is what you can do. This is the method you can be using. 2, leave the bracket, space here, 6. The next it was 10. Next there it's 15. Next is 12. Next is 8. Next is what? 4 plus next is 3. So I'm leaving the bracket. So everything divide by the total, which is 60. Okay. So now what we're supposed to put in these brackets, we're supposed to put the midpoint. So for example, where 2 is there on top, if you can see, it's from 0. The range there is from 0 to 10. So what is the number that is in between? It's 5. Between 0 and 10 is 5. Here between 10 and 20 there, where 6 is, the range between 10 and 20, what is the number in between? Is 15. Here it's 25. Here it's 35. Here it's 45. Over here it's 55. Here it's 65 and 75. So when you punch on your calculator, the easiest way to punch, let me use this calculator because this calculator is common. You just say 2 open bracket 5 plus what else? It's 6 open 15 close, just like that. Throughout you put up to 3 open bracket 75. So everything you punch on a calculator. So when you punch on a calculator, you find that your answer will be equal to, let me put it here, it will be equal to 2340. You divide by 60. There you get 39. So our mean is what? 39. So since our mean is 39 right there, we found what we're supposed to put here on the formula. So we need to find what we're supposed to put right here. Okay, so if you can see, this part and this part are almost the same. The only difference is that at x there is a power 2. So meaning we just get what everything that is here. We start putting power 2 here, power 2. So let me show you what you need to do. We have kept our mean there. So we say 2 open bracket. Okay. Close, just like that. You see what I'm doing? You see what we're doing here? This is what we need to do. Follow nicely. You follow nicely. Where are we? We're here. This is 65 power 2 plus here 375 power 2. Okay, so everything inside the brackets should have power 2, power 2, power 2, power 2, just like that. Again, over 60. So when you punch on your calculator, you punch. So when you punch here on top, you find that you're getting something like this. This is what you get. So you say over 60. So when you divide by 60, you're going to get something like this. This is what you're going to get. So this is what we need to put here. Let me write the formula so that we understand what we need to do. So this is how the formula looks. This is mean and this is what we have here. So we're just going to say root of this minus the mean, okay, squared, mean squared, this 30. So what you can do without wasting your time, you just say root of, you put the brackets there, okay, just copy minus open bracket 39 squared and then close there. What are you getting? So you find that the answer will be equal to 16.8522955. So you can just say 16.9. Okay, I've rounded it off to 1 decimal place. So that is 16.9, and this is our answer. This is how we find the standard deviation. Okay. So for question 9b, we've been given the diagrams, or I mean the tables, where they want us to answer using what we must be referring to what is on the table. So they're saying, using the table, okay, above, copy and complete the cumulative frequency table below. So they've given us the cumulative frequency. So this is one. The first thing that you need to do is to come up with this table. Put these, you copy these, okay, the way they are. This is the last part of the table. I've just gotten the last part of the table. I need to find the missing numbers, and the missing numbers here are 53, 57, and 60. I know somebody may be wondering, like, where are these numbers coming from? Very easy. It's very easy. You just start with, if you can see nicely the two tables, the one below has got a 0. So get that 0. If you want to find the next number, get a 0 plus the first number in the table there, in the top table. So 0 plus 2, it's 2. That's why you have a 2. 2 plus the next number, which is 6, you have 8. 8 plus 10, it's giving 18. 18 plus 15, it's giving 33. 33 plus 12, it's giving us 45. 45 plus 8, this is where we're getting a 53. So 53 plus 4, we are getting a 57. 57 plus 3, we're getting a 60. And remember, they have said the total number of learners is 60. So meaning, under cumulative frequency, the last number here must be 60. Mind you, it must be 60. Okay. So now we go to question 2. For question 2 here, they are saying, using a scale of 2 centimeters to represent 10 units on both axes, for 0 is less or equal to x less or equal to 80, and 0 is less or equal to y less or equal to 60. Draw a smooth cumulative frequency curve. So we need to get our ruler. Okay, they have given us the range already. So we draw something like this. And mind you, when answering these questions, we need to use a pencil, not a ruler, but a pencil. Okay, so my 0 will be right here. This is where my 0 will be. So they said up to 60, the y-axis, they gave us the range. So it's 10, okay, 20, 30, 40, 50, 60, right here. This is the y-axis. We work out the x-axis. Okay, so this is 10, 20, 30, 40, 50, 60, 70, one more, 70, and 80 right here. So this is my x-axis. So I have this Cartesian plane or x or y plane. So I need to plot the coordinates. So so if you want to, when you reach this point of graphing, you go to the table which is below. Okay, so you get the coordinates. The first is 0, 0. Second is 2, 10. So 2 is right here. It's right here, sorry, it's 10, 10, 2. It's right here, 10, 2. We're starting with the max code. That's your x-axis. So it's 10, 2. The next is 20, 8. 20, 8 must be somewhere here. Okay. The next is 30, 18. So this is 20, 18 must be here. The next is 40, 33, 30, 31, 32, 33 must be here. 50, 45, 50, 45, 40 is right here. 50 is here, 40 is right here, so 40, 1, 2, 3, 4, 5, 45 is here. The next is 60, what we have here, 60, 53. So 50 is right here, 3 is 1, 2, 3 right here. And the next one is 70, 57. So 70 is here, 53, 55, 56, 57. Okay, right here, 7, 8, 9. Yeah, right here. This is where 57 is. Next is 80, 60. 80, 60. Right here. So now we can join the points. We join nicely. We're joining the points. Remember, you must use a pencil when drawing, not a pen. The reason why they advise to use a pencil is because when you make a mistake with a pencil, it's very easy to erase. But with a pen, you can't erase. You can't delete. So now we go to the next question. This is question 2. Is it 2? Yeah, 2. We've done the graphing. So we go to the next question where they want us to find they said showing your method clearly. Use your graph to estimate, okay? To estimate the interquartile range. So interquartile range. So we first need to find the quartiles. How do we find the quartiles? So quartile 1, I'll just say Q1. This is the formula you need to use. 1 over 4 times the total number, which is 60, of which you find 15. Okay, so I found 15 there. That 15 is not our quartile 1. So we go to where 15 is. This is 10. 15 must be here. Yeah, it must be here. So when we go there, we get our ruler where 15 is. You do this up until this line touches the graph. So where it touches the graph, you draw a line down there. So what is the value which is here? This is of course 28. This is 28. So quartile 1 is 28. Quartile 1 is what? Is 28. We go to the next one. We want to find quartile what? Quartile 3. So quartile 3 is this is the method we use, supposed to be 3 over 4. Here it was 1 over 4 times the total number, which is 60. And when we work out, it will be 3 times 15. So 3 times 15, what are we getting? We are getting 45. This is not our quartile 3. So quartile 3 will be equal to, we go to where 45 is, which is right here. Right here. This is 40, 45 must be here. So we go to quartile 5, do the same like we did up to here. You drop your line, up to somewhere here. We check what number is here. It's 50. So meaning our Q3 is 50. So now to find the semi-interquartile, to find the interquartile range, we are going to say, let me indicate that this is question 3. We are going to say Q3 minus Q1. That's the answer. Q3 minus Q1. What is our Q3? It's 50 minus Q1 is 28, which is equal to what? To 22. So our interquartile range is 22. All right, so we're done with this question. We go to the next question. So for question 10, this is linear programming, and they have said answer the whole of this question on a sheet of graph paper. A businessman orders two types of vehicles, namely sedans and vans, for sale. He orders at least 60 sedans and at least 20 vans. He orders not more than 180 vehicles altogether. He makes sure that the number of vans ordered are not more than the number of sedans ordered. So question A, this is 10. Now 10A, let me put it here. 10A, they're saying, given that X represents the number of sedans and Y represents the number of vans, write 4 inequalities which satisfy the above condition. So 4 inequalities. So we can start here by saying, okay, X at least 60 sedans. So X is being represented by, our sedans are being represented by X. So this is inequality number 1. So X is greater or equal to 60. At least means greater or equal to. And Y is greater or equal to 20. This is for vans. This is equation inequality 2. Inequality 3. Okay, we're going to say altogether, because they said altogether, he orders not more than 180 vehicles altogether. So X plus Y, they should not pass 180, should be less or equal to 180. And the last inequality will be Y is less or equal to X, because they've said he makes sure that the number of vans ordered are not more than the number of sedans. So that's how it's supposed to be. So we have the inequalities. The next question here, question B, they are saying using a scale of 2 centimeters to represent 20 vehicles. So 2 centimeters to represent 20 vehicles on each axis. Draw X and Y axis from 0 to 180 and shade the unwanted region to show clearly the region where the solution of the inequalities lies. So for this one, we are going to use the range we've been given. So we can start with the y-axis, put it right there, here up to somewhere here. You do your y-axis following the range. Okay, so my 0 will be right here. This is 20, 40, 60, 80, 100, 120, 140, 160, and 180. So this is y-axis up to 180, because they said both axes should end at 180, from 0 to 180. So here you also do the same. This is bad. You do the same. Mind you, remember to use a pencil, not a pen. I'm using a pen because I want you guys to see what is happening. So almost, let me just say the same. X and Y axis is the same range. This is 100, 120, 140, 160, and 180 here. So since we have these things, we can now start doing our graphs. The first one is x is less or equal to 80. I mean to 60. X is greater or equal to 60. So you go to where 60 is here, okay? You draw your line passing at point 60, even indicate that this is x is greater or equal to 60. So greater, which side is greater is this side. Which one is not greater is less, you see, this side. So we are going to shade the unwanted region over here. This is the unwanted region. This is the unwanted region. We shade it like this. Okay, so we have shown the unwanted region. We go to the next one, which says y is greater or equal to 20. So go under y-axis where 20 is, okay? And we draw the line like that. So if we see which side is greater, is stop here. So we shade the unwanted, which is down right here. We shouldn't be forgetting to indicate that this is y is greater or equal to 20. You need to indicate. The next will be x plus y is less or equal to 180. So since there are the two of them, we know that it's passing through 180, this point at 180, and it will pass through this other 180. So now our line will just be like this. This is our line. Will be like that. Okay? This is our line. So they said is less. So less is down here. So we shade the top part, which is the unwanted. So this is the side we are shading. Okay, like that. One more inequality, which is y is less or equal to x. So it will pass through point 0. So at whichever, because they're almost how should I say, if it was an equation, we'll say they are equal to each other. So meaning they will be passing at equal points. So at 0, if x passes at 0, also y. Here it will pass through 20, 20. Here 60, where is 60? And here it will pass through 100 and 100. This side is here. So this is where the inequality will pass. So it will be like this. Oof, this is bad. That's why they say, remember to use a pencil. So if you make mistakes like this, you can erase. So we are shading the top part because y is less. Okay, so we shade this part. The region we're dealing with is right here. So these points are very important where I'm indicating here. They're very important. So the next question here, they're saying if the profit on the sale of a sardine is 10,000 and that of that on each van is 12,000, how many of each type should be ordered? Should he order to make maximum profit? So here you need to come up with what we call functional objective or objective function equation. So you're going to say 10,000, which is for sardine, and we know that sardine is represented by x, plus 12,000, which is for van, is equal to, we don't know. Okay, so our next step here will be to identify the coordinates. So what coordinates are here? This, if you can see, this is 60, 60. Here it's 60, 20. Here is 160, 20. Okay, here is 90, 90. Okay, this it's 90,90. If you can see nicely, this is 80, 90 is here, and this is 80, 90 is here. It's 90,90. So now all these coordinates, there are 4 of them. The sets are 4. There's this set of these coordinates here, here, here. So you test, meaning you'll be getting the x-axis here, it's 90, and the y-axis is 90. You go to your equation. You put 90 where x is and 90 where y is. You solve. Keep that. You come and get this 160,20. Get 160 as your x-axis. Put it where x is on this equation. This equation is very important. And 20, this 20, the y-axis, the 20 which is over here, put it where this is. Solve and check the answers that you get. So me, I'll just go direct to the needed coordinates. So it's 90 plus 12,000 here multiplied by 90. So 10,000 multiplied by 90 plus 12,000 multiplied by 90. So if you check on your calculator, what are you getting? 10,000 multiplied by 90 plus 12,000 multiplied by 90. So we're getting 198,000 as the highest profit. Okay, this is the highest profit, of which, this is question C, of which the number, okay, of vans, or let me just say sedan must be 90. Vans must also be 90. It's the one which will give you the maximum profit. Okay, and for question D, there is no need of calculating. Just go to the maximum profit that you found, which is this one. This is the solution. So you don't just pick here. You don't just pick anyhow. You need to test. So you test all the coordinates. So I've tested already. This is giving me the maximum. So once you check this one, you can also put 60 right here. Okay, 60 here and 60 here. You see the number that you get, 60 and 20. So 60 here, 20 here. You check the number that you get. If it's, and then you come and compare which one is the maximum. So the bigger profit is what you put, or the coordinates that are giving you bigger profit is what is which you get. In this case, the solution is 90, 90. Okay, that's it. Thank you. We go to the next question, question 11. So under question 11, this is transformation, and we need to use a graph paper. Okay, so the question reads, the vertices of a triangle ABC are A 40, 30, B 40, 70, and C 70, 70, while that of a triangle A sub 1, B sub 1, C sub 1 are A sub 1 is 20, 15, B sub 1 is 20, 35, and C sub 1 is 35, 35. Using a scale of 2 centimeters to represent 10 units on each axis for values of x and y from 0 to 70. Draw and label triangle ABC and A sub 1, B sub 1, C sub 1. All right, so very simple. Here we need the ruler. Okay, so we check where is our 70 falling. So you do this, very important. Okay, so this is what we're expected to do. Our 0 is right here. This is 10, 20, 30, 40, 50, 60, up to 70. Okay, this is our y-axis. Y-axis is up to 70. We go to the x-axis. So the x-axis over here. draw your line. Remember to use a pencil. This is 10, 20, 30, 40, 50, 60, and 70. This is our x-axis. All right, so we start with coordinates for A, B, C. So A is 40, 30. So it's 40 here, 30. It's supposed to be here. Okay. This is our A. B is 40, 70. So 70 is right here. Okay. This is our B. C is 70, 70. So 70, 70 is somewhere here, because this is 70, 70 up there. So indicate C. So now we can use our ruler to join the points. So we have this right here. Also have this and these. Okay, so this is our triangle ABC. So we draw now A sub 1, B sub 1, C sub 1, of which A sub 1 is 20, 15. According to the coordinates we've been given, 20, 15 must be somewhere here. Right here. Next is, and this is our A sub 1, subscript 1. Our B subscript 1 is 20, 35. So 20, 35 must be somewhere here, because this is 30, 31, 32, 33, 35 must be here. This is our B subscript 1. Next is subscript C, which is equal to 35, 35. So 35 is right here and here. Okay, 30, 31, 32, 33, 34, 35, 30, 31, 32, 33, 44, 35. Right here, this is our subscript C subscript 1. So we join the points. We join. This is what we're expected to do. We go to the next question, which is question B. So for question B, they are saying fully or describe fully a single transformation that maps triangle A, B, C, A, B, C, okay, B, C onto triangle A subscript 1, B subscript 1, C subscript 1. So this is, of course, the opposite of enlargement, because it's coming from this to this. If it was from this to this, it could have been enlargement. Now, from the bigger one to the small one is the opposite of enlargement, which is the reduction. So we're going to write our solution right here. We can say B, we start with the transformation. We can say reduction, comma, center of reduction. This is 0, 0. I've said 0, 0. It's because I know where it's falling. So what you need to do, you join the corresponding points. So A1 and A2, okay, these are corresponding points. So you join them, you're just testing, use the dotted line like that. You see it's passing at the origin. So this is C, and the C over here, you can also join these corresponding points. So if you can see, this line is passing through the center. The other line is also passing through the center. You can even join this if you want BB. So I'm joining the BB. They're also passing through the center. So This is the center of reduction. It's 0,0, and it's what I've put here. The next will be to find the scale factor. Scale factor. In this case, the scale factor is 1/2. Okay, 1/2. So what you normally do for you to find the scale factor, which is k, or if you want, you can just say k is equal to 1/2. It's just the same. So for you to find the scale factor, this is what you do. So you get the sides. Okay, you get side. You start first of all, you start with the image. The object. And in this case, the object is let me say k is equal to, the object is this one. This is the original. It's this one. Actually, it's this one. Let me see. If I messed up, let me check which one is the objective. It was from this BB to this to this. Yeah, so we get the image. We start with the image. So it will be B1 C1, okay, over BC. Okay, so you just get the corresponding side. So I've gotten this side over this side. So if you check nicely, the length or the difference between 30, because B1 is at 30 and C1 is at 15. I mean, it's at 35, of which here, when we work out things, we find it to be 15. And this one, the difference here is what? It's 30, because this is 40 and this is 70. So the difference is what? It's 30. So you write over 30, of which 15 into 15, 1 into 30 is 2. This is how we found the scale factor to be 2. The 2 which is right here. I mean, to be 1/2. The 1/2 which is right here. So we go to the next question, which is question C. For question C, they are saying a rotation of 180 degrees, about 20,40, okay, maps triangle A1, B1, C1 on two triangle A2, B2, C2. Determine the coordinates of A2, B2, and C2. So this is what they are talking about. The center of rotation is right here, because this is where 20,40 is. So 180, this B will move up to somewhere here. Let me find a pencil so that I show nicely, or the compass, I show nicely what is going on here. So this is what you can do in case you don't know what is going on. You can put your compass here and then open up to the point that you'd like to, the point that you'd like to bisect the other side. So when you do this, you find that it's falling somewhere here. So this will rotate 180 like this. Will come to this point. 1, 2, 3, 4, 5 to this point. So this is our B2. This also A will rotate somewhere this side. Okay, so it will be right here. Right here. 1, 2, 3, 4, 5. Yeah, this is where it will be, and this is our A2. You see, this A will rotate 180 up to here. C will rotate 180 up to somewhere here. 1, 2, 3, 4, 5. Yeah, up to here. So this is up to here. It's supposed to be right here. This will be our C2. I followed this point. I was supposed to follow this point. So now you can join. You can join the points. So this will be like this. My drawing is not good. Yeah, like that. This also like this, and this one like that. So now we need to get the coordinates, because they said determine the coordinates. So this is our C. So for C, we'll start with our A2. Our A2 is 20,65. So 20,65. We go to our B2. Our B2, this is B2 over here. B2, it's here. So B2 is 20,45. 20,45. Go to our C2. Our C2 is right here, which is 15,45. 15, sorry, 5, not 15, 5,45. This is 5 actually. Right here it's 10, so 5, this is 5, if you can see it's 5,45. So these are the coordinates for C. We go to D. Question D, they're saying triangle A1, B1, C1 is mapped onto triangle A3, B3, C3 by a single transformation with vertices. So A1 is 40,15. So we can start plotting. So 40,15 is right here, because this is 1, 2, 3, 4, 5. Yeah, right here. This is A3. Okay. B3 is 40,35. It's right here. So this is where our B3 is. C3 is 70,35. It's supposed to be somewhere here. Here. So this is it. C3. So now we can join the points. We can join the points. This is how the triangle will look like. So we're done there. We have drawn. But the other question says describe. Okay. Describe fully this transformation. So this transformation here is stretch. If you can see, it's moving. It's the same. This triangle is the same as this. But now this one has been stretched this way. Okay. It has gone this way. So you can say it's what? Stretch. Stretch. You can also find what we call the invariant line. So invariant, in this case is x is equal to 0. So x is equal to what? To 0. Okay, x is equal to 0 right here. So it's coming from here going that way. So now to find the stretch factor. So the stretch factor here, I can say k is equal to, okay. If you want, you can just say the length from here, from this invariant line, which is x is equal to 0, to C, where C is, C3 is, it's at 70. So you can say, let me use this part. You can say 70, because we want to find k, 70 over, sorry. Yeah, actually, this is what you're supposed to do. You can say 70 over from here to where the other C is. The other C, this C is on 35. So 70 divide by 35. You are getting a 2. So meaning our K here is a 2. All right. We move to the next question.